Hello students, I am VK Singh. Welcome to the class. We are continuing our discussion of geometrical optics, and today we will start our discussion on reflection of light. So you all understand that reflection of light is very important in our day-to-day life, and the discussion of reflection is done under two headings. One is reflection at plane surface and another is reflection at a spherical surface. So first of all, I would like to tell you, I would like to discuss the reflection at plane surface. So here is a plane surface and this is the incident ray, this is the reflected ray, and this is the normal. This is angle of incidence, this is angle of reflection, which is equal, and this is the angle of deviation that you understand. I1 incident ray, I2 R1 reflected ray, and normal. This is the angle of deviation, and in this angle of deviation we can understand I is equals to R. This is law of reflection, you already know. Incident ray, reflected ray, and normal lie in the same plane. What does it mean? Normal will not come in this way. If incident ray is in the plane of board, reflected ray is the plane of board, this cannot be normal. It should be also in the plane of board. Now here this complete angle is 180 degree. So deviation is how much? Deviation is 180 minus I plus R. This is your 180 minus 2I, because I is equals to R. This is deviation. Deviation produced. Deviation is what? Ray is going in this direction, it has turned in this direction, then this angle is your deviation. The angle by which the incident ray changes its direction, that is your deviation. And this is your normal plane reflecting. Now in the process of reflection, light comes back in the same medium. Here it is air, and reflected is also in air. And in this process, the velocity of light changes. Speed does not change, velocity changes. Why? Velocity is a vector quantity and the direction has changed, so the velocity has changed. Here also the speed is 3 into 10 to the power 8 meter per second. Here also the speed is 3 into 10 to the power 8 meter per second. But direction is changed, so velocity is changed. So this is the way we have understood the reflection, and on the primary scale, on the primary level. Now if you write this equation, delta is equals to minus 2I plus 180, and compare it with y is equals to mx plus c. This corresponds to c, this is x, this is m, this is y. Then naturally the graph between delta and I is a straight line. Here you see, if I am taking a graph between delta and I, here is delta, here is I. It is a straight line with negative slope. It is a straight line with negative slope. If I see this point, at this point I is 0, so I is 0, delta is equals to how much? 180, so this point is 180. Here delta is 0, here delta is 0, so I is how much? Delta is 0, so I is equals to 90 degree, so it is your 90 degree and 0. This is the 2 point. These points have a specific name. Now see carefully. If I take a reflecting surface in this way, and this is the incident ray, and this is the reflected ray, this is the normal. What is the value of I? The value of I here is your 90 degree. I is equals to 90 degree and deviation is equals to 0. Why? Because the incident ray this is incident, this is reflected. Incident ray has not changed its direction. It has gone in the same direction. So now we would like to understand that in case of plane mirror, how the image is formed and what is image and what is object. The main question, a student reads whole the optics and do not understand what is object and what is image. In terms of optics, point of intersection of incident rays is called object. For example, here is a plane mirror. Here is a plane mirror. This is incident ray. This is incident ray. Here is the point of intersection. When this is the point of intersection, this is object. Which type of object? Real object. And according to law of reflection, this will be the reflected ray. This will be the reflected ray, and here the image is formed. Which type of image is there? Point of intersection of reflected rays is called image. So this is reflected ray I1, R1, I2, R2. So point of intersection of reflected rays is called image, but it is not actual intersection, so it is virtual image. So plane mirror forms virtual image. So can we say that plane mirror always form virtual image? No, real image can also be formed by plane mirror. How? If the rays are converging, that means object is virtual. See how. Here is the plane mirror. This is the incident ray. This is the incident ray. These incident rays are converging. If rays you are considering, this ray represents the parallel rays. Meeting at a point, these rays are converging rays. These rays are diverging rays. In converging rays, the distance between rays goes on decreasing. In diverging rays, the distance between the rays, two rays, goes on increasing. And in parallel rays, the distance between the two rays remains the same. So if it is converging ray, then they will converge at a point like this. So this is your point of intersection object. But which type of object? Virtual. Why? It is not actual intersection. Then reflected ray will form the image. This will be your image I. And which type of image is this? This is real. So this mirror, plane mirror, M1, M2, M1, M2. So we have seen that the plane mirror forms real image with virtual object and virtual image with real object. So this thing we should understand in a proper way. So plane mirror forms both real and virtual image. Real image is the point of intersection of reflected rays, actual point of intersection. Virtual image is the appeared point of intersection of incident rays. Object, real object, actual point of intersection of incident rays. Virtual object, appeared point of intersection of incident rays. So this is real and virtual object that you should understand for building up the concept in optics. Here we are discussing a question, that is, two plane mirrors are inclined at 70 degrees. A ray of light is incident at an angle I on one plane mirror. After reflection, it falls on the other mirror in such a way that finally gets reflected in a direction parallel to the first mirror. Find the value of I. So two plane mirrors are here. Basically it is the application of geometry, class 10 geometry that you have read. A ray of light is incident. This is not parallel to this. It has gone. But finally reflected ray, this is parallel to this first mirror. This is parallel to first mirror. And you have to say that what is the value of this angle of incidence is equals to how much. Pause the video and then solve by yourself. If you are able to solve, very good. Otherwise, then you see the solution. So, this angle is 70 degree. In the question it is mentioned. This angle is 70 degree, so this angle is also 70 degree. Why? Because it is the corresponding angle. Here is the normal. So when it is the normal, this angle is 20 degree. This angle is again 20 degree. So this angle is 70 degree. So this angle is 40 degree. This angle is 50 degree because it is normal. 40 plus 50, 90. So I is equals to 50 degree. So in this way, we have got that by applying the principle of geometry, we have got that the angle of incidence in this case is 50 degree. This is one aspect, that how ray optics is geometrical optics and how the basic principles of geometry are used in your ray optics. Plane mirror case is there. Image formation by plane mirror. Here you should understand that whenever we are forming the image, the law of reflection should remain valid. It should not be violated. So if a plane mirror is here and if an object is here, two types of objects we consider in optics. One is point object, one is extended object. So this is extended object. This is AB is extended object. So ray will go, this is falling normally, so it will retrace back. One ray will go in this way, incident ray, this is angle of incidence. So it will, here is the image, A dash, B dash is formed. One thing you should understand, that in case of plane mirror, this distance, if x, this distance is also x. Object distance is equals to image distance in case of plane mirror. That you can prove very simply by the use of geometry. This angle is I and this angle is R. Here I is equals to 0, I is equals to 0, so R is also equals to 0. So what type of image is there? Image is erect and it is virtual and same size. So same size image is being formed. So plane mirror forms virtual image of same size. It doesn't mean that, as I had discussed earlier, it doesn't mean that it will not form real image. Object is virtual, it will form the, now you will, if the object is virtual, it will form the real image, or the rays are converging, then also it forms the real image. One term is there that is called lateral inversion. What is that lateral inversion? Try to understand. If a letter P I am writing here, then in mirror it will appear. See, this is the line, it will have the equal distance. Here will be the image. This point is nearest point, so here it will be the nearest point. Object distance is equals to image distance, and then it will be in this way. This phenomenon is called lateral inversion. Laterally inverted image is there. What is important? The cause of this lateral inversion is that object distance must be equal to image distance. But in certain symmetrical situation, you may not observe lateral inversion. For example, if I am taking the letter O, it will have the same in this way. Only thing is that this portion is here and this portion is here. So there is no lateral inversion. So lateral inversion is basically this one. Now, after discussing the lateral inversion and after discussing the image formed by plane mirror. So one more example I am giving. If I am taking a plane mirror in this way and here is the object, then what type of image you are expecting? It will be near point, so here near point. It is the far point, so it is the far point, so you will be getting the image in this way. This thing also you can understand that if this is the AB is the object, this is A dash B dash is the image. Now after this we should understand one more thing about the plane mirror, that in plane mirror law of rotation, if the mirror is kept constant, if the incident ray is kept constant and the mirror is rotated by an angle theta, then reflected ray rotates by 2 theta. This is a very important theorem, very useful theorem. So if the plane mirror is here, and this is the incident ray that we have kept constant, this is the reflected ray. If I rotate the mirror by an angle theta, suppose this angle is theta, then reflected ray rotates by 2 theta. This angle is 2 theta. Here, very important, that if the mirror is rotated in clockwise direction, the reflected ray also rotates in clockwise direction. And if the mirror is rotated in anti-clockwise direction, the reflected ray also rotates in anti-clockwise direction, keeping the incident ray fixed. So incident ray is fixed. Incident ray is fixed. We are not disturbing the incident ray, only we are disturbing the mirror. Mirror M1, M2 is rotated. So these points you should know in mind. Also one thing you should understand, that in the same mirror, in the same plane mirror, if the plane mirror is kept fixed, and the incident, suppose this is incident ray, this is reflected ray. If the incident ray is rotated in this way, this is the direction, reflected ray also rotates in this way, this is the direction. So if the plane mirror is kept fixed and incident ray is rotated in clockwise direction, then reflected ray rotates in anti-clockwise direction. If the incident ray is rotated in anti-clockwise direction, then reflected ray rotates in clockwise direction. This is very important, but the amount of rotation will remain same. Here it is theta 10 degree, 20 degree. Here it is 10 degree, then also it is 10 degree. It is 20 degree, then also it is 20 degree. Only difference is that here opposite direction, here same direction. Now I would like to give one more example in which the use of geometry is there. Basically it is the property of similar triangles that the sides are proportion that we will be using in this question. Suppose there is a wall. This is a wall, height is h, here is a mirror, in between the wall and mirror there is a man M, not in the midpoint. This distance is x, this distance is y. You have to find the minimum size of plane mirror. So that the man M is able to see the complete wall, image in mirror. Now in this question, looking at the question, you will give the answer something half the size of man, like that only, but it is not correct one. First apply the concept and then try to get the result. Basically, you have to understand in this way that suppose this is top and this is bottom of the wall. Then to top become visible, the ray of light should incident, and after reflection it should fall in the eye of man. Similarly, from the bottom also the ray of light should fall, and incident light should fall on reflected light should come on the eye of the man. So this is the size of mirror from here to here. It is the size of the mirror that is of use. This has got no use at all. So take it as M1, M2. Now how to find? Your answer should contain H, X and Y, because H is given, X is given, Y is given. So the size of mirror should be in terms of H, X and Y. So here what I would like to tell you, we will apply a little bit geometry. How? Here is the man, so its image will be here. This is the man image, and this will be your wall that we are getting, the complete wall. Take this point as O and this point as P. Now, as I told you, we will apply the concept of geometry. What is that concept of geometry? Similar triangle concept. See, TOB, this is a triangle similar to M1O M2. This triangle and this triangle are similar, and if the triangles are similar, then what will happen? Sides must be proportional. So triangle TOB is similar to triangle M1O M2. So what we will get? This side by this side, that is TB by M1 M2 must be equals to this perpendicular bisector. I am giving the name OPQR. Take this perpendicular bisector RO by this perpendicular bisector OP. Now put the value. TB is how much? TB is your H according to question. M1 M2 we have to find. RO X plus Y, this is also Y. Object distance is equals to image distance, so this is also Y. So X plus 2Y by OP Y. So what is the size of mirror? M1 M2 is equals to HY by X plus 2Y. This is the size of the mirror, that minimum size of the mirror that is required by this man to see this wall completely in this mirror. Now here different questions can be framed. Put different value of H, X and Y and you will get the different sizes of mirror. If it is 2 cm, it is 1 cm, it is 3 cm, the answer is different. If it is 5 cm, it is 4 cm, it is 10 cm, answer is different. Like that only, different values you can, 5 meter is there, like different values you can put and you can get the different result. Here one more thing is there for the discussion that should be understood by you people, that if the man is in middle, if the man is in middle, that means that is x is equals to y. This x must be equals to y. If x is equals to y, then m1 m2 is equals to h by 3. Directly you can give the answer, provided the man is in the middle of between wall and mirror. H by 3y, y, this x is equals to y, so y plus y 2y plus y 3y, so hy by 3y, that is h by 3. So this should be the minimum size of wall, this should be the minimum size of mirror, so that this complete wall is visible to the man. So this is the way we have applied the concept of geometry in this case also. Now in plane mirror, one more question is there that is related with mechanics, particularly the relative velocity. That in this question, in this understanding, the velocity concept is there in case of plane mirror. That also we have seen in the question bank, that object speed is this much, then what is the image speed, like that only. So I am giving one concept to you that will clarify the whole situation. Wherever you will apply, you will get the correct answer. Suppose this I am trying to discuss with an example. Suppose here is a plane mirror, m1, m2. Here is the object. This object is moving with 2 centimeters per second towards the plane mirror. You can take it in this side also, no matter, it makes no difference. And this mirror is moving with 3 centimeters per second. Mirror is moving in this direction with 3 centimeters per second. Then what is the velocity of image? Velocity of image is how much? This concept, in order to apply, now this can be extended. This example, by learning this example, you can solve any question of this type, of this profile. Why? You can make the object at rest, you can make the mirror at rest by making this as 0, or making it in this direction or in this direction, whatever situation that you can create. This is the master concept that I am trying to give you, trying to make you understand. What is here velocity of image? Now if this distance is xom, at the equal distance xim, image is there right now. Now here I will be using one concept from mechanics, that is relative velocity concept. And what is that concept? VAB, relative velocity of A with respect to B. VAB is equals to VA minus VB. VAB. This is the relative velocity concept that I will be using here. So here what, and little bit differentiation I will be using. Here what can I say? XOM is equals to XIM. Can we say in this way? No, we cannot say. If one boy is here and one boy is here, that doesn't mean that they are at same position. So here negative sign should be there. This is also the function of time. With time it is changing. This is also the function of time, because with time it is also changing. So I am doing the differentiation, time. So dxom by dt must be equals to minus dxim by dt. Now in mechanics you have read rate of change of displacement with respect to time is velocity. So I will write this as velocity om is equals to minus velocity Im. This is the velocity relation. Now I will apply the relative velocity concept, that is velocity of object minus velocity of mirror minus velocity of image plus velocity of mirror. According to question, velocity of object is given 2, but be careful. If you will take this direction as positive, this direction you will have to take as negative. If you want to take this direction as positive, then this direction has to be taken negative. I am considering this, you will consider the reverse situation and you will try to get the answer. The magnitude will come same. It is not that this will be positive, this will be negative than the other answer, and this will be negative and this will be positive than the other answer. It is not like that. So carefully see what I want to tell you. Velocity of object I have taken 2 minus 3 minus velocity of image. Velocity of mirror is minus 3 plus minus 3. So what we are getting? We are getting velocity of image is equals to minus 8 centimeter per second. This is your answer. Now minus 8 means what? Minus 8 means minus only tells about direction. This quantity tells about direction. Minus it means that the image will be moving in this direction. That's all. And you can apply any number of situations in this concept and you can get the answer correctly. Why? Suppose if mirror is at rest, you make it 0. If the object is at rest, you make it 0. Use this one. And if the mirror is moving in this direction, and if the mirror is moving in this direction and object is moving in this direction, then also you can find. So by this concept, you can find the velocity in any situation, and in this way you have understood this matter. I hope that this understanding will remove your confusion about the velocity of object and image. In plane mirror, this much is sufficient for giving answer to the questions related with plane mirror that is being asked in examination. So I hope that if this much amount of preparation of plane mirror you will do, then from plane mirror you will not be in a position to leave any question. So in next class I will be talking about the spherical mirror, that is the curved mirror, and we will see the curved mirror, the concave and convex. You already know, you already understand it, you have read it in your junior classes. So in next class we will discuss about the curved mirror. Till then, goodbye, have a nice day.